Hey guys, so today I want you to talk a little about a problem that we have in the backend called the tethering hurt, and I will try to explain what happens exactly. So imagine that your application something changed in the backend and you need to notify the front end that something changed. You could have like some WebSocket connections that already establish like open connection between your browser, all the browser from all your customers to your backend application, and then you send events there. And the problem is that when something changes, you send an event for the front end, and the front end from all those browsers that are connected will send API requests to refresh whatever they have in the screen to get the latest updates. And we saw like a ton of API requests that will arrive at the same time to the application, and we try to execute everything into the database, and the database will can execute fast when it's just one API. It's just a few executions. But when we have a ton of query executing at the same time, it just like slows down a lot and will time out, and the application will time out, and then you see many and many API requests failing, and basically your application will explode there. You can solve this on many different ways. First, you could just in the WebSocket event, instead of sending all the events at once, you could just send to one browser, then space a little, and send to another. But this could cause other problems. You could also send a payload in the WebSocket event, so your front end application doesn't need to send the API request and can update the page with all the information that you have already in the payload of the event. But there are some limitations there. Depends on the implementation of the front end. So you have many different issues there. You can also change the technology. You don't need to use a WebSocket. You could use some other streaming or some other ways of doing this. But in the end, we could have other scenarios where the Thunderbird ends up in your application and you have like tons of API requests arrive at the same time. So what could we do in this case? I created a tool that can also be used as a library, call it Anicetus. And what this thing does, it just works as a semaphore, to be honest. It when all the API requests arrive at once, this Anicetus will detect if first if it is a problem, like if we do have like a thundering hurt. And the way it does that, it uses a token bucket. So it say, okay, in the last minute, 1,000 requests happen. So this is not usual. So this is a thundering hurt. Or you could change its parameters. You can change like every second, 1,000 requests in a second or something like that. So it's really flexible. Like we use it like in the library. We already have like a token bucket implementation, but it's flexible to change to whatever you want. In like if you want to change the way you detect that is a thundering hurt. So after it detects there is a thunder alert, you say, okay, everyone stop, and just one API request that arrived from this thunder alert will pass through to the backend. And this one request will go to the application, will be executed by the database, and it's just as it's just one API request, it will execute fast enough. We go back to the application, and that's the important part. When it goes back to the application will cache the response from this API request, and then it goes back to Anicetus. Anicetus will just pass it back to the front end. But the important bit is when it passes back to the front end, it will say, okay, so that single API request that was executed in the backend, it already completed. So I assume it's cached. So all others API requests that were being blocked by the standard herd will now be allowed to pass. So now all the API requests we go direct to the application, and the standard herd will start hitting the application. But this time, you already have the response cached, and your response and all those API requests won't hit the database anymore, won't hit your backend infrastructure. We'll stop at the caching layer of your application, and we'll go back directly to the browser. So no more problems, no more explosions there. Some important bits. First, you need caching. If you don't have caching in your backend application, this is useless. You don't want this. Second important thing is grouping of API requests. If every API request from the standard herd that is feeding your backend has a different response and you can't group them somehow, this is also useless because in the end, all the API requests will arrive at any status. It will say, okay, this is a different response. This other is also a different response. This other is also a different response. So all of them will pass through the application and you will have the same issue with or without Anicetus. So you need a caching layer in your application, and you need to group the API requests somehow. You can group them by the domain of your API request. You can group them by the path, by the query string, by maybe all of them, or maybe by a header that represents the session. Maybe all the API requests from the same session have the same response. And like all those combinations you can do there is really flexible on how you detect this. And we call this the fingerprint. So how you group them is the fingerprint of this group. And by default, we give like an HTTP grouping strategy where you can extract things from the HTTP request, but it's also flexible for to change it for other protocols. So you can have like a binary protocol and implement your own detection system and fingerprint system there to say, okay, this bytes represents a group or something like that. So when this group arrives at the status, only one will pass through from this group, will get cached, and then after this one gets cached and returns to the status, then all API requests from this group will hit the backend. So that's the important bit. And everything is pretty flexible. Today we have the Anicetus is using a lot of like in-memory strategies just because we don't want to add too many dependencies to the project. But it's really flexible to change and plug in new strategies. Like for example, we want to keep the state of like if this standard herd from this group is happening or not, and what is the status? Is the API request that sends to the backend already executed or not? So all these states today are stored in memory by default, but you could store it in Redis, you could store it in maybe some relational database or whatever you prefer. And so it's really flexible to change there. But by default, you only have like in memory and available inside the repository there to avoid dependencies. But yeah, I think that's it. And if you have any questions, please give me a shout. We have like a discussion section in the project there, and I'm happy to collaborate there. And hopefully, you can improve this project and more, even more. I hope this resolves the issues that we have in the backend there with regarding the standard herd. Right? Thanks, Amidan, and have a good one.